So yesterday we have covered the J.J. Thomson atomic model. Do you remember that? So J.J. Thomson atomic model is also known as watermelon model. Do you remember the topic yesterday we studied? Yes. So in that we have the merit and demerit. So what is merit and demerit? That is nothing but the advantages and disadvantages. So in the J.J. Thomson atomic model, so the main important advantages is we can able to get the idea how the atomic structure will be present and how the electrons are embodied in the form of a watermelon. We learn that how the electrons are embodied. Okay, and we got some idea about the subatomic particles, the arrangement of and subatomic particles. But the default is, that is the demerit is, because we could not able to point out the presence of negatively charged electron in the atom. So that is about the default of the or else demerit of the J.J. Thomson. Now today's section, whatever the defaults are there, the drawbacks are there. So that is studied by the Rutherford, and he given the explanation in the form of Rutherford nuclear model of an atom. So now today's section we are going to learn about the Rutherford nuclear model of an atom. So this is introduced in the year 1911. Okay, so he explained this activity or this experiment in the form of a alpha ray scattering experiment. Please do understand. Okay, so he explained the complete model, the nuclear model in the form of an alpha ray scattering experiment. Alpha ray scattering experiment. So in this experiment, he took the gold foil, a small thinner layer of the gold foil. Okay, he took the small thinner layer of the gold foil, and the source is alpha rays. Okay, so the source is alpha rays. So in this alpha rays, two protons and the two neutrons are present. So it means that it is a helium. Okay, it is a helium. Helium plus 2. Okay, the source is helium. So this helium is present and you can see a small hole, a small minute hole. So from that, the ray which passes and hit to the gold foil. And whatever the ray is detected by the detected screen. So this detected screen is known as fluorescence. Is it clear all of you? Once again you listen. Some source is present here. Like example, if you have a bulb is the source. From that you can see the light rays will be false. The same way, here also a source is present. In this you can see alpha rays. So that's what we call it as alpha rays. Okay. In the alpha rays, which element is present? Helium. Okay. In the alpha rays, which element is present? What is the main important source there? Helium. Okay. So the helium is in the form of an ion. The ray is reflected. The ray is the source which is moving to the straight line and hit to the gold foil. Okay, so this is the gold foil. And do you know how much the thickness is there? It's very small thickness. The thickness is 2.1. I'm writing here. So 2.1 into 10 to the power of -7. So that much of small thickness the metal is. Okay, 2.1 into 10 to the power of -7 meters. So 2.1 into 10 to the power of -7. So that much of very thin gold foil is present. So when it is heated to this gold foil, okay, then it will be detected and the ray will be false like this. Okay, and how can you say that the ray is falling there? By the sparkling light. So you can see a spark light will be found here. Okay, so this is the experiment. This experiment is known as alpha ray scattering experiment. So in this, what you are going to learn. So this is the experiment. See, when the source is moving from here, it will be heated to the gold foil, and you can see some detected paths are there in the fluorescence. So this is the experiment. So in this experiment, what we learn? So that we are going to learn. Okay, so think that this is only one atom. the gold foil. Okay, suppose if it is a gold foil, you know that so many atoms are present. Now we are selected only one atom. Okay, so we have to know the conclusion. So that is the reason I am selecting only one atom. Now the ray is heated and the ray is moving towards the another side. And here also you can see the ray is moving to the straight line. So when the ray is moving towards the straight line, when it comes in the middle, so it is detecting out. Okay, again when it is coming here, it is detecting out. It is not moving into the another direction. Okay, it is not moving into the another direction. Why? Why? Suppose you think that I have a chalk piece. Now I am hitting to that side. So the chalk piece is moving straight. But if I hit to this side, so what happens here? So it is coming back. So it is bounce back. The same way, by this activity, we understand that something mass is present here. So mass is present here. So due to that reason, the ray is reflecting out. Okay, so that is the reason why it is divided to the another direction. So when the ray is falling here, it is diverted. So it is diverted to the another direction. So why it is diverted to the another direction? Because some mass is present in the nucleus. Some mass is present into the atom. So finally they said that whatever the mass is present, that is only called as a nucleus. Is it clear all of you? So now when it comes here, again it will be bounced out. Okay, when it comes here, the ray, so what is the ray? Alpha ray. So when the alpha ray is hit here, it is bounced back. So why it is bounced back? Because a mass is present here. So finally they said that mass is known as the nucleus. So by this experiment, they given the conclusion that the nucleus is present in the center of the atom and the electron is present. The electron is present to the another side where it is revolving around the nucleus. Is it clear all of you? So by the alpha ray scattering experiment, they given the conclusion that the nucleus is present in the center. Okay, the nucleus is present in the center and it starts positive charge. Okay, it has positive charge and the electrons are revolving around the nucleus. Like how the planets are revolving around the nucleus, how the planets are revolving around the sun, the same way the electron is revolving around the nucleus. So that is the reason why they are saying it has nuclear model of an atom. Is it clear all of you? Now listen one more time. So because of the alpha ray scattering experiment, we got the conclusion that in the center of an atom, okay, the center of an atom, some mass is present. So the mass we call it as a nucleus. And in that nucleus, protons and neutrons are present. And electrons are revolving around the nucleus, like how the planets are revolving around the sun. The same way, the electrons also revolving around the nucleus. Okay, so that is the reason we call this model as Rutherford nuclear model of an atom. So we'll also call it as nuclear model. Okay, so this is the first important point we have to understand. And next, from this activity, from this experiment, what we understand? Presence of nucleus in the atom. Okay, presence of nucleus. Okay, presence of nucleus in atom. So this is the point we learned from we got the conclusion from the alpha ray scattering experiment. And the second important thing is, most of the atom is compared to the nucleus and the atom. So atom is bigger in size and nucleus is present in the center of the atom. So most of the atom have hollow space. Okay, so hollow space. So the most of the atom has the hollow space and small center point is known as small center point is called nucleus. So do you understand? Atom. So atom, see whenever we are passing the rays, the ray is moving front. So the ray is moving forward direction. So it means that so much of hollow space is present. See if I throw the chocolates from the window, so it will be moved front. It won't be detected back or it won't be bounced back. Okay. it means that the atom consists of lot of hollow space and the center point, the small center point. This now we studied no in the center point. So that is known as a nucleus. So these two conclusions we got from the alpha ray scattering experiment. Okay. And next one what we learned? We learned that this type of this atomic model we call it as planetary model. Okay, so this model we call it as planetary atomic model. Already we wrote here. So the nuclear model is also known as planetary model. So why we call it as planetary model? Because like how the planets are revolving around the sun, the same way the electrons also, where it has a negative charge. So the negative charge of an electron is revolving around the positive charge. So where the positive charge is present, so that is a nucleus. So the electrons are revolving around the nucleus, like how the planets are revolving around the sun. So that is the reason why we call it as a planetary model, and it is also called as nuclear model of an atom. And you know that for this reason only he got this. Rutherford got the Nobel Prize. Okay, so he got the Nobel Prize. Do you know the year? In the year 1908. Is it clear, all of you? So this is about the Rutherford. But here also we have the advantages and disadvantages. First, we have to know about the advantage. So what is the advantage of this Rutherford nuclear model? The first important thing is we got the information about the position of an atom. See, when we studied about the watermelon model, we don't have the clarity information about where the electrons are present, where the nucleus are where the neutrons are present, where the protons are present. But here, due to this alpha ray scattering experiment, we got the clear information about the position of an electron, position of a proton. We got the defect orbital, means we got some idea about how the orbit is present. Okay, so where the orbit is present, when the electrons are revolving around the nucleus, we get some path. So that path is known as orbit. So by this Rutherford model, the main important advantage is we got the position of an atom. The position of an subatomic particles. That is the electron. So we understand that electrons are revolving, and we understand that nucleus is present. In the nucleus, proton and neutron will be present. Okay, and we understand about the defect of the orbital. So this is the main important advantage from the Rutherford nuclear model of an atom. Now come back to the disadvantage. So what is the disadvantage here? We cannot able to explain about the stability of an atom. Okay, Rutherford could not able to explain about the stability of an atom. So this becomes the drawback. So for that also let me give the explanation part for you. Just now I said that positive charge is present. So the positive charge is known as nucleus, and the electrons are revolving around this nucleus. And what is the charge of the electron? Negative charge. So we know that negative charge is revolving around the nucleus. See, whenever I say to, if I give this path and if I say to run in that path, are you going to run in the same path continuously for the longer time? No. So when you are going on running, then after some time you will come here. Isn't it? The same way here also, the nucleus. The nucleus is present here where it has a positive charge, and electrons are revolving where it has a negative charge. So when it is going on revolving, so there is a chance of attracting to the positive charge, and it may fall into this, and the atom may be collapsed. Okay, when the negative charge will attract the positive charge, when both comes together, what happened? The atom will be collapsed. But this is happening? No. Atom is stable in nature. So this particular thing is not explained by this complete clear information is not given the explanation by the Rutherford. So this becomes the disadvantage of the Rutherford. Is it clear, all of you? You understand what are the important points of the Rutherford model? And next we studied about the merits and demerits, that is known as advantages and disadvantages of the Rutherford. Is it clear, all of you? Let me ask you the question. So when this Rutherford nuclear model has proposed, in the year, what is the year? Please start in the chat box. Which year? Yes, exactly. 19th level. Okay, now tell me, when Rutherford got the Nobel Prize? In which year Rutherford got the Nobel Prize? Yes, exactly correct. No, 1908. 1908. Okay, 1908. What is the advantage of Rutherford? What is the main advantage by using this alpha ray scattering experiment? What is the main advantage of the Rutherford? Tell me in one sentence. Yes, ma'am. Yes, position of an electron and position of a proton. Yes. Next one, what is the disadvantage of a Rutherford? What is the disadvantage of Rutherford? Rutherford, he can't able to explain the stability of an atom. Yes, correct. So he can't able to explain the stability of an atom. So this is about today's topic. So in this today's topic, what we learn about the Rutherford atomic model. So what is the most important point? We learn this experiment. We learn this Rutherford model in the form of an experiment. So what is that experiment called? Alpha ray scattering experiment. So in the alpha ray scattering experiment, what is the main important source? Alpha rays. So in the alpha rays, what is the source there? Helium ion. Helium He plus 2. Okay, so helium plus 2 is the important source. From that we'll be getting the alpha rays. And alpha ray is hitting to which coil? Gold foil. And what is, yes, very good, gold foil. And tell me, what is the thickness of the gold foil? 2.1 into 10 to the power of minus 7. So that is the thickness of the gold foil. Okay, and where you can able to see the sparkings when the ray is hit, where you can able to see the sparkings. So that is known as fluorescence. Okay, so the ray will be hitted to the. So this is the gold foil. So it will be hitted to the detector. So this detector is known as fluorescence. Okay, or else we call it as detector sheet. Okay. Next, what is the next important point from this alpha ray scattering experiment? What is the conclusion we got? What is the first important conclusion we learned from this experiment? That is the presence of nucleus in an atom. Okay, the presence of nucleus in an atom. So what is the next important point? Most of the atom has hollow space and tell me. Small center point is the nucleus. So that is the second important point we learned from this. We got the conclusion from this alpha ray scattering experiment. And next we understand that by this only they conclude the nuclear model of an atom. So that is also called it as planetary model. So why we are naming it as planetary model? Because as the planets are revolving around the sun, the same way the electrons are revolving around the nucleus. So that is the reason why we call it as the planetary model. And next, what is the next important point? Yes, advantages and disadvantages. Okay, what is the main important advantage? Again, can anybody will repeat? Position of an object is the advantage, and the second one is stability. So you couldn't explain about the stability of an atom. So this is about today's topic about the Rutherford nuclear model of an atom. Okay, now if you have any doubts, you can chat in the chat box so that I can give the answer for you. So before that, please do the attendance there. Please write on your roll number. We just got to